In this video, I want to give an example of the big push model. This is a simple model of complementarity, coordination failure, and multiple equilibria. As we know, the problem that we face in the world is that for some countries that are currently underdeveloped, it can be hard to get economic growth and development started. But once it gets going, it is easy to actually keep it going. And it's a real problem because in standard economics, we cannot explain this phenomenon. Instead, standard economics like the solo growth model would argue that if you are poor, then you should grow faster because you don't suffer from diminishing marginal returns as much. Given that standard economics cannot explain this problem, we're looking for new models to address this issue. And what we have come up with is the contemporary models of development. And again, the big push model is one example of such a model. In order to keep the big push model simple, we have to make some strong assumptions. So we're going to assume first that the country is closed. There is no trade, no foreign investment, no foreign aid. And what that means is that there is no external demand for the country's products. And therefore, only the nation's own workers will be able to buy the goods produced. We're also going to assume that the country starts out as a subsistence economy, which means that the workers do not have extra money to buy goods produced using modern technology. So workers in the subsistence traditional sector cannot afford to purchase goods produced using modern production techniques. So what these two assumptions give us is that only workers in the modern sector can afford goods produced by the modern sector because they're going to be paid a wage premium. But a modern factory cannot sell all its goods to its own workers. In fact, we're going to assume that all workers buy all goods. Thus, in the beginning, there is not sufficient demand for goods produced by the modern sector. In fact, sufficient demand will only be achieved if there are many modern firms hiring many workers and therefore paying them a higher wage. So you need a critical mass of firms using modern technology in order to pay sufficiently many workers a high wage so that they can afford buying the goods that are being produced by the modern sector. So here we have the complementarity and the coordination failure that shows up in this model. The complementarity is that one firm's decisions to use modern technology depends on other firms also making that decision. Okay, so given those general assumptions, these are the formal assumptions for the model. So we assume that the number of workers is fixed. The number of workers is either in the traditional sector or using modern technology. We're going to normalize everything so that the workers in the traditional sector is paid 1, and the workers working in the modern sector is paid a wage premium, W, and that is higher than 1. There are going to be n types of goods produced, and n is a large number. And as I mentioned before, all workers will consume all goods. There's a traditional production function, Q equals LT. That is, we have normalized everything here so that output is equal to the number of workers. So each worker produces 1 unit of output. That's the marginal cost. And we have constant returns to scales because if we double the number of workers, we will double output. In the modern production function here, we have Q equals minus F divided by C plus LM divided by C. What does that mean? Well, F is going to be the fixed cost. So it takes a certain number of workers, let's call them supervisors, to start producing production using modern technology. And then each worker can produce a certain number of goods. So this is the marginal cost of the modern worker, and the marginal cost is less than 1. So when you look at this one here, what it really shows us, and it's hard to see it right here, but in order for modern production to be worthwhile, you're going to need to have a lot of workers in that industry, because the average cost will go down as you add more and more workers, because then you can spread the fixed cost over more and more output. So in order for the average cost using modern production technology to be lower than the average cost of using traditional production technology, we have to produce a lot in the modern sector. Anyway, so these production functions here are true for all of the end goods. So all end goods are using the same technology, and they're all exactly the same. And then again, like I said before, all workers consume all goods. All right, so given this one, what I'm going to do now is I'm going to put some numbers to this model, and then I'm going to go ahead and solve it, and hopefully I'll be able to show you that we need a big push. That is, we need to coordinate that many, say, farms start using the traditional, or move away from the traditional technologies and start using the modern technology instead. But before I give you the numbers, let's just look at this diagram. This is a standard diagram for this big push model. And what we have here is that on this horizontal axis, we have the input, the number of workers. And on the vertical axis, we have the output. We can assume that the price of the product is 1, and therefore, if you have the units being produced and you multiply it by 1, well then output and revenue is going to be equal to each other. Alright, so according to the traditional production function, I've drawn that using this green line here. And as you remember, output is equal to number of workers. So, and all the goods are exactly the same. So if all workers are working in a traditional sector or using traditional methods, then each good will have L divided by N numbers of workers producing it. And therefore, the output level will be L divided by N over here. I might even write that down. So here's L divided by N. Now, if all the workers switch over to using modern technology, then they will be producing using this production function. And if I just plug L divided by N into my production function, I'm going to have some higher, or I mean, I don't know that, but the way I drew this picture, I would have a higher level of output over here, and that's going to be my revenue. And of course, one could ask, how much will it cost to produce that level of output? Well, in the traditional sector, the cost of a worker was equal to 1. So to produce this many units, the revenue would be equal to L divided by N, and the cost would be equal to L divided by N. So basically, it's a competitive market here, and the profit will be equal to 0. Now, for the modern production function, if I did the same thing there, so if I looked over here, you can see that the revenue will be equal to whatever they are producing, but the cost will be, of course, the number of workers multiplied by the wage premium. That's going to be given by this point right here. And since the revenue is higher than the cost, there is actually a bit of a profit here, greater than 0. So if that was the case, if everybody switched over, then everybody would make some profit, and therefore all firms would, after the fact, conclude that they made a good decision. Now, one thing that happens in this model is that because it's very competitive, so we're going to ask ourselves, what if one one farmer decided to switch over to using modern technology, would that be worth his or her while? Well, because if one farmer switches over, basically the amount of income in the country will stay exactly the same. It is true that there will be a few people being paid a wage premium, but that's going to be such a small effect. That income effect can be ignored, and therefore whether a farmer should or should not do using the modern technology, should make that switch, will then depend on if he or she can make any money. Well, if the farmer is the only one switching, then because income is the same, everybody will be buying the same amount of good as they always did, and therefore the revenue to the firm will stay the same as it did when they were a traditional sector. So we will still be on this line right here. By using the modern production function, we can produce, it will take this many workers, whatever that is, and the cost of using those workers will be given by the red line there. And actually, if you look at this picture, it's going to be really hard. It looks like it's about the same. But in this case, it would actually be that, well, one firm might actually want to go ahead and switch, even if no other firm does it, because the revenue is slightly higher than the cost. However, this is going to be, of course, dependent on what the wage premium is. For example, if I had drawn a different curve, suppose I drew the wage premium like this, you can see that in that case, the cost will be higher than the revenue, and therefore they make zero or negative profit. So no firm would want to make that switch. And of course, if it was even lower, then it would be even more likely that they would actually make the switch. So what this shows us is that the numbers really matter. Anyway, I'm going to give you one example. In this example, I'm going to use a wage premium that gives us an interesting result. And the interesting result is that the wage premium is high enough so that no firm would want to be the only one switching. But it's not so high that if all the firms switched, then they would still, everybody would make money if all the firms switch. All right, so these are the numbers I'm going to try to set up in the next slide. All right, so I have decided to use the following numbers. I'm going to suppose there is 1,000 workers in this economy. They're producing 100 different types of good. The fixed cost of producing using the modern technology is 4. That is, you need 4 supervisors, say. And the marginal cost, which is less than 1, is 0.2. Right? So basically it says that each worker can produce 5 units. And I set the wage premium equal to 2. Using these numbers, I was able to draw the following diagram. So notice here that I have output on this axis, and again the price equals 1, so the output equals revenue, and we have input on this diagram. And if everybody is working, if you split the number of workers over all the industries equally, then you'll have L divided by N, which is 1,000 divided by 100. So you're going to have 10 workers working in the traditional sector here. And if they all work there, you can see that the amount of output and revenue is going to be equal to 10. And the wage premium is this green line over here. And you can see that since the wage premium is 2, the slope of this line is twice as steep as the slope of the traditional production function. And then the blue line shows the production function for a modern, or a business that's using modern technology. And you can see, we're just looking at this blue line here, like if they don't produce very much, or if they don't use a lot of workers, then the output will be lower than it would be for a traditional producer. But as the number of workers increases, output increases, because you can start to spread that cost, the fixed cost, across more and more units of output. And the way I have it set up here, you remember that Q was equal to, maybe I'll just write that down. So Q was equal to minus the fixed cost, 4, divided by the marginal cost, 0.2, plus the number of workers in the industry divided by 0.2. So when we have 10 workers, we can see that we have minus 20 plus, so that's 10 divided by 0.2 plus 50, so that's equal to 30. So that's what I have drawn this curve to show. And you can see that the slope of that whole thing is equal to 5. 1 divided by the marginal cost. Okay, so now the question is, should, well, first of all, let's figure out what the benefits are for these different alternatives. So if we have only traditional, we knew that the revenue is going to be 10, the cost is equal to 10, and the profit is equal to 0, which is fine. You know, in competitive market, a 0 profit is actually a pretty good one. Now, if we only have modern technology, then the way I drew it here, because then if every worker is working in a farm that uses modern technology, there will be 10 workers in every farm, so therefore the revenue will be equal to 30. And the cost, well, we can see what the cost is. We have to draw it out there, but if you have, it's going to be W times the number of workers, so that's going to be 2 times 10 equals 20. And therefore, we can see that the profit in this example will be 30 minus 20 equals 10. So clearly, if we could coordinate so that everybody switches over to using the modern technology, then everybody will be better off. Well, let's see if there's any farmer who wants to be the first one to make the switch. So only one farmer switches. What happens then? Well, if only one farmer switches, we would have to calculate a few things here. So as I said before, because if there's only one farmer switching and therefore very, very, very few people actually getting the wage premium, and therefore the income will stay basically the same, and therefore you can only sell 10 units. So even if you use the modern technology, you can only produce 10 units because that's all that you can sell. Remember, there's no external demand, so only workers within your own country can actually buy this good. And since their income has not changed, if they were able to buy 10 units for every type of product before, then they will still do that now. So the revenue is going to stay at 10. So if I were to go over here on my diagram, what we can see is that they're going to be at this point. We can go down here and see how many workers they need when they have, how many workers do you need to produce 10 units of output? We can plug that into our equation actually. So you remember that Q was equal to minus 4 divided by 0.2 plus LM divided by 0.2. If I just solve this for LM, and you can go ahead and do that if you want to, it turns out that LM equals 6, which fits with our picture as well. And how much will it cost to hire 6 people in using modern technology? Let me make that a little darker. So the cost would then be W times L, and the wage premium is 2, the number of workers is 6, and therefore the cost is going to be 12. And therefore here we see that if one firm is the only one making the switch, the profit will be equal to 10 minus 12 minus 2. Well, what you see, and we could see that in our diagram as well, that if only one firm switches, then that one firm will lose money unless all other firms switch at the same time. So if you ask me, would it be worth the while, or would a firm be able to make any profit by being the only one to switch? The answer would be no. And if that's true for any firm, then it's true for all firms, or all farmers in this case, and therefore no farmer will switch to using new technology, which means that our initial outcome with subsistence, in a subsistence economy, we're going to be stuck there, and that's going to be what we have before called a poverty trap. So what is needed? Well, we need some deep government intervention. So if the government could come in, do something so that all firms will be willing to make the switch, then we can move from a poverty trap to a high income outcome. So what would that entail? Well, you could, of course, just give all the farmers the new technology, or you could subsidize the new technology. You can see, for example, that if they said, like, if you adopt a new technology, we'll pay half of your wage premium that you have to pay for these workers. Well, then the cost would go from 12 to 6, and suddenly each farmer would have an individual incentive to make the switch, and everybody will switch, and everybody will be rich because of it. Anyway, we would need the government to do some kind of intervention that helps coordinate the actions of all these 100, all the 1,000 people and the 100 products that are being produced in this good. All right, so that's the general idea of the of the big push model, and this is just a simple model of that, and of course one could make it more complicated, but this simple model does tell the story the way we would want it to be told. Thank you very much.